Hey, it's been a few weeks since we've done a tutorial and I feel like I owed you guys one, and I know a lot of you are asking for the lower body inverse kinematics and how to do that procedurally and not even using animation. So today, that's what we're going to do. I'm going to show you guys how to make your player walk procedurally without even doing any animation. This video is going to be based off of one that Unity did for procedural walkers for a game they made. So it should be pretty fun. And I know a lot of you have been asking for the procedural hands video. I know that's coming. It'll be in a couple weeks. I think next week I'm going to do an update to my game that I'm making, and then the week after we'll do another tutorial. I'm going to hire an editor soon and try to get into a rhythm of doing one tutorial and then one kind of extra video a week, like a devlog or a gameplay video or a review or something like that. So I want to do more tutorials, and I want to keep this channel's bread and butter mainly tutorials, but I also want to kind of branch out into other stuff that doesn't get as taxing on my brain, as it were. So look forward to in the next month or two, I'm going to hire an editor and start getting up to 2 videos a week, which is really exciting. So without further ado, let's jump into it. If you have not watched the upper body IK video, I recommend you go watch that now and then come back. It should be on the screen now. That's going to set you up to be able to finish out this tutorial here today. So I have already gone through this and did a test, but let's add a new project. I have copied and pasted the old project, the old upper body tutorial, and just pasted it and renamed it. So that's what this is. And then we're going to update the version to 2020.3.11. This is the most recent long-term support version. And then let's open it and confirm the update. There we are. And I'm going to tone the gizmos down a little bit. And then as you'll remember, we have this XR rig, which we're actually going to disable for now because we want to be able to play around with this guy without the XR rig interfering. And then we have the character, and we have this rig 1 that we added for the hands and head. And this is how your project should be set up right now. First thing we need to do is go into Window, Package Manager, and then go to Packages and In Project, and we need to go through and update each one of these packages that has an up arrow next to it. And if you don't have one of these packages installed, especially the XR ones or the OpenXR plugin, you'll need to make sure to install that. There we go. All our packages have been updated and have that green check mark. Now, if you've scaled your legs down to 0, you're going to want to go back and scale them back up to 1, obviously, because this video is about making the legs move and we need them to be there in order to do that. If you're not seeing this bone structure here, you're going to want to go to Animation Rigging and click on Bone Render Setup, and that will outline all of the bones on your character for you. Make sure you have the character selected when you do that. And Animation Rigging is just a Unity asset you can download from the package manager if you don't have Animation Rigging. Alright, so let's just start setting this guy up. Let's first rename this Rig 1 to Rig Upper, and then we're going to click on the character and then go to Animation Rigging and Rig Setup, and that's going to make a new rig for us, and we're going to name this one to Rig Lower. And then just like we have with the upper, we're going to want to make a new game object underneath, and we're going to call this IK Leg Right. And then on this IK Leg Right, we're going to add a component to Bone IK Constraint. We used this in the last video, so you guys should be pretty familiar with it. We're going to want to grab the tip of the right leg. So I'm going to click on this guy, drag that over, and then right click on the component and auto setup from transform. This will automatically create for us a target and a hint, and we're going to want to line up the target and the hint with the respective placement. So to do that, let's click on target and then hold down shift and click on the bone that we want to line up with, and then go up to Animation Rigging, Align Transform, and then do the same thing for the hint. Click on the knee and then Animation Rigging, Align Transform. And then for the hint, we actually want to bring the hint out pretty far and up a little bit. And this is the target for where the knee is going to try to get to. So when our character picks his leg up, we want the knee to always try to go up. Now let's repeat this for the left leg. Right click, new empty game object, IK Leg Left, to Bone IK Constraint, grab the tip, right click, auto setup, and then we take the target. It's kind of weird if you click on both of them in the hierarchy, you'll need to hold down Control to get both of them, but if you click on one in the hierarchy and the other outside in the bones, you hold down Shift, which is a little confusing, but whatever. Make sure those are both aligned, and then let's take the hint and drag it out again, like we did for the other. We could even make sure they're relatively lined up with each other. There we go. Now these targets and hints alone don't really do anything by themselves. We need to add a script to them to make the leg seem like it's actually walking procedurally and taking into account the other leg, and only one is going to be up at the same time. And to do that, we need to add a custom script. And I know some of you guys don't like the coding parts of my videos, so if you don't want to script along with me and type it all out, I have the script available now as an asset, so you can just download this scene as an asset into your current Unity project, and all you have to do is go to my Patreon and support me at the lowest tier. And you get access to all my source code, every single tutorial I've done on this channel, and I really appreciate all of you current patrons. It really helps me continue to do these videos and hire editors and buy equipment and that kind of stuff. All the money I make out of this YouTube channel goes directly back into it, so I really appreciate you guys. Plus, you know, it saves you some time on coding. So check out that link in the description and in the pinned comment. And for the not faint of heart, let's get into coding. So on the IK leg right target, we're going to add a component, and this is going to be a custom script. We're going to call it IK foot solver, and then create and add new script. I'm going to drag this over into the scripts folder, make sure to stay organized, and then double click to open it. The overarching goal of this script is to calculate the distance that a player's traveled, and if the distance is greater than a certain amount, we want the player to step. We also need to take into account, is the other foot in the air, is what's below the player actually ground, and some other things like that. But the general idea is we need to step for the amount of distance that the player has traveled. And we're not going to be using any animation or anything like that. This is all going to be procedural in the code, so you don't have to worry about any kind of animators or anything like that. So let's set up some variables. We're going to have a lot of serialized field private, so I've just copied that and we're going to paste that a few times. First thing we need is a layer mask, and this is going to be whatever the ground layer is. I'm just going to call it terrain layer. We need a body. This is going to be the actual character game object, and it's really just going to be the center position of the body so that we know how far we've traveled. We need an IK foot solver other foot. This is obviously going to be the other foot. We're going to use this to reference the other foot and check and see if it's in the air or not. And we're going to need a lot of floats. We want a speed. This is going to be equal to about 5. I've found that works pretty well. A step distance. We're going to set that equal to about 0.3f. A step length, which is going to be equal to the step distance. So whatever you set the step distance to, you also want the step length to be about equal to it. And then we want the step height, and that's going to be equal to, let's go with 0.3 as well, usually works. These are all values you want to adjust for your specific character and how fast you want them to move. Your step distance and step length is going to be different. Step height is really based on how tall your character is. So if your character is taller, you're going to want a larger step height, and that's going to be how high they pick their foot up. And then we're going to want a couple vector 3s. We want a foot position offset and a foot rotation offset. This will help us orient the foot to the ground and prevent our foot from going through the ground, and also in case the terrain is sloped or whatnot, this will help us rotate our foot to align to that. And we want a couple private floats. We're going to have a foot spacing and a lerp values, and then we want some vector 3s. We're going to have an old position, a current position, and a new position, and then some more vector 3s. These are going to be the normals, so old normal, current normal, and new normal. And obviously the serialized fields will be editable in the editor, so these are all fields that we can configure. So we're going to want to set what our terrain level is and what the body and other foot and all of the values for speed, step distance, and all that kind of stuff. And these values down here we want to not be able to change. We want to just change it in the code, and so I designate that with the underscore in front of them. So the underscore values are private values and can't be changed except for in the code. Let's go to the start method and initialize some of these values. We want foot spacing to be equal to the transform local position x value, and the current position is going to be we're going to do this cool little trick. So you can set multiple variables in one line by just doing equals equals. So we're going to set the current position, we're going to set the new position, and we're going to set the old position, set them all equal to transform dot position. So this equals 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 will set everything to whatever the last value is. And we can do that with the normal as well. So current normal, new normal, and old normal are going to be equal to transform dot. And then we're going to set the lerp value to 1. Now let's get into the meat and potatoes. So every time we update, we want to set the foot to the current position and rotation. So we're going to do transform dot position is going to be equal to the current position, and transform dot up is going to be equal to the current normal. And keep in mind, this script is just for 1 foot. So we don't need to take into account multiple feet or movement or anything. All we need to take into account is this one specific foot. So we need to take a ray from the body down to the ground. So let's make that. We're gonna have a ray, new ray. So the ray is gonna start at the bodied position, and then we want to offset it by the foot spacing. So if we're using the right foot, we want to offset the ray cast by a little bit to the right and point down straight from the right leg. And that's what our foot spacing value is for. So we're going to say body right times foot spacing. And that will offset us to the left or the right based off of the foot spacing. And then we also want to go up a little bit just in case the center of the body is through the floor somehow. So we're going to do a vector 3.up times 2. And this will just start our ray cast from 2 meters up. And then the direction we want the ray to go is vector 3.down. And then let's have an if statement. And if the ray actually hits something, we want to continue and do what's inside of this if statement. We're going to have a physics raycast. We're going to input the ray, and then we want to get a hit out if we hit something. We're going to say out raycast hit, and we'll call that hit. We want the ray to go a maximum of 10 down. That's probably more than far enough to hit the ground beneath us. And then we only want to hit the terrain layer value, which means we're only going to register the ground. We're not going to, bump into the player or whatever the player is holding. We only want to register ground. So right now our lerp value is at 1. And when our lerp value is at 1, we're not moving the foot. Now we want to move the foot if we've gone a certain distance. So we have a raycast and we have a raycast hit. Now we need another if statement to see if we've moved over a certain distance. So we're going to say vector3.distance, and it's going to be the distance between the new position, which is currently its current position, but we're going to set it down later in the update method, and the hit point. So is the distance between where we want to go and the hit point greater than the step distance. And we also want to make sure the other foot is not moving. So we're going to call other foot is moving, and we want it to not be true. So if the other foot is not moving, and this method is going to be a method that we make. So let's go ahead and make this down here. This is going to be really simple. It needs to be public because we're referencing it from another class. And then this is just going to return a bool. It's going to be called is moving. And all we're going to do is return if lerp is less than 1. So if lerp is less than 1, that means that the foot is in the air, still moving, and we want to skip over any actions that we're going to perform. So that's what this is for. And we also need to make sure the current foot is not moving in order to update where we want to go. So we want to make sure both feet are on the ground before we update this foot. So if we've arrived at the specific distance that the step distance is, if the other foot is not moving, and if this foot is not moving, then we can update the position and step. And that looks like this. So we're going to call lerp equals 0. We're going to have a direction because the character can move anywhere in 2D space. So we want to have a direction forward, backwards. This is going to be body inverse transform point. It's going to be the hit point. This just converts the world space to local space. We want the Z value of that. And if it's greater than body inverse transform point of the new position, Z, then we are moving forward. So 1. And if not, then we're moving backwards. So -1. Oh, I covered that up. Realized I might have been covering some code up. So here's the extra little bit of code if I was in the way. And then we also need to set the new normal and the new position. So new position is going to be equal to the hit point plus the body forward times direction. So this will say front or back times step length. And then we also want to add the foot offset, position offset. And my IDE writer always wants to reorder multiplication for whatever reason. So, and we also want to set the new normal. And this is going to be equal to the hit.normal. And then we're going to add the foot rotation offset. There we go. So that updates the point that we want to go to every time we update, but the feet are not actually moving at this point. So we want to actually move the feet. So what happens if the lerp gets set down to 0? We want the foot to move kind of like in a sine wave, it has that little arc. We want it to move in a little arc to this next point. And in order to do that, we're going to have another if statement down here. And this is going to be if lerp is less than 1. So if lerp is greater than 1, it's going to go into this if statement here. But if it's less than 1, we're going to come down here and it's going to work on moving the feet until it gets greater than 1. And then it's going to do another check to see have we got enough enough distance to do another step. So we're gonna have a vector3 temp position, and this is gonna hold a vector3.lerp, and that's gonna be the old position, new position, and the lerp value. So this will move the old position just ever so slightly closer to the new position based on the value of lerp. So lerp is a value from 0 to 1, so you can think of it like a percentage. And so if lerp is 0.2, then it is going to move the old position 20% closer to the new position. And so that's what our temp position is. So our temp position is going to be 20% closer to the new position. And then we want to get the temp position.y value, and then we're going to add to that the mathf.sign lerp times mathf.high times step height. So this line here is what's going to move the foot upwards in an arc in a sine curve. And so it's going to make that, arc that we like to see when we're walking. It's not just like you move your foot straight to the next point. You have a little arc to your step. So this will create that arc. And then we're going to set the current position equal to the temp position. The current normal is going to be equal to vector3.lerp between the old normal and the new normal. Since we don't have to actually do any adjustments to this, we can just straight set that one. And then the lerp value is going to increase over time. So we're going to say time delta time times speed. So we can adjust how quickly the foot lerps over this distance by the speed value. And then we're going to add an else statement here. Else, so if we've gotten all the way down to 1, then the old position is just going to be equal to the new position. And same with the normal. So old normal is going to be equal to the new normal. That just means we've finished this step. So we're going to set the new position to the old position. And there we go. That's the code. And I'm going to add one more method down here. And this is just going to help us in the editor. We're going to make an onDraw gizmos. And we're just going to say gizmos color is equal to color.red. And then we're going to say gizmos draw sphere at the new position. So it's going to draw a sphere at where the foot is headed. And we're going to have a radius of 0.1. And that'll help us visualize where the next step is going and, help us out in the editor a little bit. So there we go. This is all the code. I'll give you a little bit over this if you want to, copy it or whatever. Let's save this and go back to Unity. So you want this script on the IK leg R target. We're going to set the terrain layer to default because that's what this layer is. We want the body to just be the root of the character. Other foot is going to be this guy, which we need to drag and drop here as well. So body, drag and drop the other target as the foot. And then all of these values should be good. Drag and drop the other foot as the target. And I've disabled this XR rig because I don't want to jump into it and, go through that whole thing. So make sure you save, and then I'm going to hit play, and the game window is not going to have any cameras, but we can swap back over to scene view. And if you click on the XR rig, you can manipulate the player, and as you can see, as we move forward and backwards, we walk, and it's a pretty natural looking walking motion actually. And you can move forward and backwards and also side to side, and the player will dynamically adjust where their feet are going. And as you can see, if I move it too fast, then the step distance isn't really the step distance and speed don't really match up. So you'll want to adjust that for what your character's max speed is. And you'll also notice that the feet here are wacky, and you're gonna have to adjust that inside of the position offset and rotation offset. So you'll want to adjust the position to get your foot just on top of the surface, and then the rotation obviously to get it even with this level surface. And once you get those two adjusted, you have a nicely walking around character. All procedural without any animation, without any animators or anything, which is super cool. And you'll also notice that as we get higher and lower, we automatically crouch too, which is nice. And like the legs even have that slight offset to them, like you would when you're like crouching a little bit. Like that's really cool. And he'll try to adjust. So I'm going to spend a minute adjusting the offsets, try to get this nice and looking good, and then we'll play with it inside of the actual VR headset. Let's jump back into the code real quick for a second. I have adjusted the offset code a little bit, so I took it from down here. So we were adding the offsets on these two lines here, and I am adding the offsets here in the update because I wanted to be able to dynamically adjust them instead of just adjusting them every single step. I wanted to be able to, just drag the slider and it changed there on the spot. So by adding it to these two lines, you'll notice all I did was add the position offset onto the current position, but the quaternion one, I updated this transform to, instead of be transform.up, it's going to be transform.rotation, and then we have a quaternion look rotation, which is the normal, and then we're multiplying that by the offset, and that's how you do the quaternion offsets. This is a much improved version over what we had just written, and it allows you to adjust the offsets on the fly instead of having to, move your play around and whatever. And here we go. If we grab our XR player controller, one more thing. So I noticed an issue with the first, like when you initialize, the feet weren't being quite correct. They're at a weird angle, and that's because we're setting this current normal, and instead of using the hit normal, which is a little bit different, we're just using transform.forward or we're just using transform.up. So I've added this variable is first step equals true up here, and then inside of this if statement I've added this is first step here, and then put the rest of it inside of parentheses, and now this is going to fire once at the very beginning to reset the foot position so it's at the correct orientation, and that should solve that problem. And here you go, you have a working walking character that will move around and procedurally walk, and the feet will adjust to the floor's orientation, and there you go. Like I said earlier, all this code is available. If you don't want to type it all out, it's all available for you on my Patreon page. I really appreciate any support you can give me, and I've got something exciting to share with you guys next week. Next week I'm giving an update to the game that I'm making, and you get to hear the story next week, so that's really fun. I have a really exciting story, and I think you guys are gonna love it. It's kind of Far Cry-esque a little bit, but anyways, stay tuned for next week. Also, if you run into any issues on this project or debugging or anything like that, you can join our Discord server. There's a link to it below, and if you need some help, there's a specific channel for that, or you can just leave a comment. I respond to every single comment on every single one of my videos, so if you need some help that way, or just have a question you want to ask me, please leave a comment. I love chatting with you guys, and I will see you in the next video.